Well, while we're waiting, I do want just to say thank you to you, Kelsey, for helping to organize this and for asking me to help. I think it's been a great experience. And I also want to recognize our early career folks again. So Ferris, Amanda, Cass, Marie, and I can't remember the name of your postdoc, Kelsey, who helped
Zach.
yesterday. Zach. Oh, I'm so sorry, Zach. All of you did a fantastic job with supporting us. I don't think we would have been able to do this without any of you. So we really appreciate it. All right. So let's see. Should we get started now, Kelsey?
Sure, I think the number of
All right.
participants stopped dramatically increasing.
Okay. And I also do want to recognize Survey and your support for running this, especially Ricky, and all those folks have been running slides. You guys did a fantastic job. Thank you so
And
much.
also want to give shout outs to the Lunar and Planetary Institute who helped us build
Yes,
the program, take registrations, and manage all the abstracts. Debbie Mitchell in particular just was absolutely instrumental. And
absolutely.
also shout out to Jose. Thanks for all your hard work for this, Jose. Really appreciate it. It's been a real pleasure. And we'll keep the fun rolling for the report generation.
Oh yeah, the fun continues. All right, so let me real quick share my screen here, and we'll see if we can make some sense out of the notes I was taking over the last hour. So breakout session number 1, we talked about infrastructure. So these are all the various questions that I had, at least at the beginning. There's a highlighted sort of part here, digital space, and it turned out that a lot of what our discussion sort of focused on with respect to physical space was the question of, is it even really needed? And there are strong arguments for maintaining physical space. Physical interaction is really important, especially since we can't really, we can't split headsets and put one ear on one meeting and another ear on another meeting infinitely. So we need some physical interaction. But there are tools now, as we've all experienced over the last year, to enable distributed science teams to operate in a meaningful way. Some other comments that we got with respect to space is the need for flexibility. So as the Artemis program proceeds, early missions might need different physical spaces than later missions. And so we should maybe plan for reconfigurable spaces, maybe multiple spaces with different purposes. And in the vein of distributed science teams, maybe we have science teams sort of distributed in various places that do have different functions and that they physically meet periodically, much along the lines with how Mars exploration has been run. In terms of virtual spaces, there's need for communication and that can be sort of, spur of the moment that we can use to replace sort of the, just tap someone on the shoulder or sort of walk over to their office kind of moments that we all value. In terms of tools and instrumentation, seems like there's lots of lessons to be learned, perhaps from things like the mining industry. That could be a topic for maybe a future workshop. Can we learn in terms of tools and instrumentation, data streams from those kinds of operations? There's a recognized need for a top-down approach to organization of data. So from sort of a digital tools perspective, how do we organize and add metadata to all these data streams in such a way that they're easily searchable and can be used and interconnected. So how do we do that? There is a need for software to be similarly sort of interconnected and intercompatible. So a coordinated ecosystem, if you will, of software tools, and then documentation that describes how those interact. There's a question I think is a really good one of, how do we store this data in a way that is compatible, say, with the planetary data system? Is there something about how the PDS is organized or how human spaceflight data is organized that maybe makes those incompatible that we can fix? And then communication. So communication tools, especially if we're going distributed, tools to enable that are going to be key. So something like Slack for science operations would be needed. Virtual reality and other sort of visualization tools. We need to understand sort of what the requirements are to make those work in order to understand what kind of data streams we need back from the lunar surface. And then finally here, edge computing. So what kind of computing can we do in situ on the lunar surface to pre-process data, to enable things like machine learning. What kind of hardware do we need that's radiation hardened and so on to enable that? And finally, before I turn it over to you, Kelsey, we talked a bit about communications. So there's a question about how many comm channels are enough or too few. Perhaps one EV comm channel for both, or however many EV personnel there are. Maybe that's too few. There's limitations to that. Transcription of voice communications. It's still primitive to do that with software, even with Alexa nowadays. So is there a way? Oh, am I muted? I hope I'm not muted.
No, you're fine.
Okay. Oh, I was looking at Microsoft Teams and I'm muted there. Okay, so real-time transcription. It's still primitive to do that with software. So there's a comment about maybe we need to use trained transcription folks who are familiar with the voices being transcribed. That's probably the best we can do. And then finally, especially if we're going along the route of maybe having job jar sort of get ahead tasks for crew, perhaps a model for communicating with them offline, perhaps not during the EVA, is having office hours. Right, I'm a professor. I can relate to that. Having office hours with the crew where they can interact and talk about the science that they're doing on their own in addition to what's being done during the EVAs. Anyway, that's sort of a rundown of everything we talked about. And I will stop sharing my screen.
Awesome. You succeeded far more than I in coming up with cohesive bullets that summarize your discussion in a short amount of time. So apologies that I'm not nearly as organized as Jose. Okay. Okay, so we kind of broke our discussion down into 3 key areas. Science team roles and responsibilities. So kind of like what are the broad responsibilities of the science team in general, traverse planning and science definition versus actually like tactically executing those science objectives. And then we also want to talk about how to encourage and facilitate participation of the next generation, as well as communication with the broader science community. And then we want to talk about science team structure. So how many sub-teams exist? What kind of does the org chart look like? What are all the, personnel and positions that need to be staffed within the science team? And then finally, communication. So how should the science team interact and communicate within each other? What's the final decision-making authority for decisions? And then this whole kind of Capcom versus SciComm debate, for lack of a better word. Again, sincere apologies. I was trying to synthesize these very quickly. So for those in my breakout, don't worry, we have the notes and we have the recording. So if I didn't capture this correctly, we'll make sure it's captured correctly in the report. So we recommend avoiding the term backroom and instead choosing a name more appropriate to the highly integrated nature of lunar surface science operations. A lot of nomenclature was thrown around, but I think we can all agree that backroom is not appropriate. Facilitating next-gen involvement, there was a lot of great conversation, especially in the chat. I'm excited to spend more time looking through that. But we want to advocate for dedicated seats and involvement for early career folks. Could be through the role of documentarians, but the importance of actually getting hands-on experience for those folks rather than just observing was mentioned. Jim had a couple really great concrete ideas. One was teaching, which it would include the development real time of geologic exploration exercises that somebody on the team would be designated to getting out to classrooms worldwide so that they could kind of follow along with the progress of the lunar cruise. And then just broad outreach, the idea that Jim had that somebody should be available to comment to the public on the geology real time so that people can kind of be brought along with that sort of spirit of discovery. And then made the point, I think it was Noah that made the point that including the next generation in the years and months prior to landing, rather than just, obviously real time during ops, could allow more people to be involved as well as, to ramp up an experience for the next generation, leading up to the landing. Noah also made the point that participating science programs have been really valuable, and this could be, if we adapted that type of program to support human exploration, that could be a way for, not, in the years prior to the mission, but they could be these sort of quicker reaction time programs could allow for flexible and sort of closer to real-time deltas to what we originally envisioned the strategies for support being. We want to evaluate whether science needs to have a position in the front room that's sort of parallel to the EVA thicker, the EVA front room position, rather than somebody who's in the sort of next level down EVA support room. And we wanted to define science. It could be just geoscience, but it also could include biology and human health objectives, as well as heliophysics and astrophysics objectives. And there was a lot of advocates for making it a really integrated position that could speak to all of those different types of objectives. A lot of points made that future missions will include robotic traverses as well as crewed traverses. So more thought needs to be put into how that science support function of each type of traverse will interact with each other, because a lot of these robotic assets could even be provided by international or commercial partners. And that a finding is that we need to track this as sort of an unknown, because we're not really sure how that architecture is going to evolve over time. We want to ensure that whatever structure we come up with is evolvable, because as we progress to longer term lunar missions as well as Mars forward missions, we want to make sure that we have a structure that can react to those changes. And the highlight that we should have a sort of a science manager as a single point of contact to the flight control team to minimize the crosstalk. The second high level topic we talked about was science team structure. I tried to capture kind of like all the positions that were mentioned. This is certainly not conclusive. Jose and I need to like dive back through the records to kind of capture all of them, but flight director, obviously, above the science team, but thinking about how we interact with that EVA FICR position, whatever EVA science officer is and where they sit, Capcom versus SciComm, which we'll talk about in a minute, a science lead. We talked about the importance of an imaging team and a mapping team, as well as an integration lead that sort of bridges the gap between decisions that are being made over multiple timescales. Somebody to talk about managing data needs, as well as safety and hazards, especially from a science perspective. We talked about, Oz brought up the point about an instrument lead versus kind of like instrument data analysis and how we manage that depending on what the mission science objectives are. Cass mentioned the difference between a science lead for operations versus a science lead for like science objectives and tracking science objectives, so that the tactical decision maker probably might not be able to be the same person as the science decision maker. We talked, this kind of feeds really well on what we talked about yesterday, and that we want an ops and engineering focus in the science team as well, or at least that touch point to the operations and the engineering folks, just like there will be the science touch point in the ops and engineering centers. And some of those roles could be scheduling, planner, that's the same thing, and kind of the relevant instrumentation and technologies. Again, we mentioned this in the previous slide, but talked about the different modalities for doing science, need a way to link all of these different science teams. Didn't make a ton of progress on the actual like kind of structure, but we did have some thoughts about breaking it down by instrument or by science question. Jessica Watkins made the point that we want to consider what the nature of the interaction with the crew is going to be, because that will then drive the structure of the science team. How autonomous the crew is expecting to be will really influence how the scientists structure themselves and kind of what information they're expected to feed back on what cadence. And because I know we're out of time, science team communication. Of course, we want to find a streamlined comms architecture, and we had a long conversation about this like SciComm idea. Alex brought up the point that the nomenclature I think needs a little bit more discussion, but we really need to factor in the complexity of the science and the task we're talking about. There's some lessons learned from doing science ops on station, but that's inside the habitat versus EVA. And the thing we can all agree on is we really need one voice for EVA, and we need that person to not just be an expert in science, but to be able to speak to all mission objectives as well, especially in the areas of that timeline where it's a bit higher risk. But we do want that one voice who's speaking to the crew to be an extension of the science team, which means that person, if they're not a scientist, really needs to be really highly trained, just like the crew is going to be. And then the last 2 points are the debrief periods, rather than just the quick, short, brief comms that are happening during the EVA. Those debrief periods are really critical for really evolving and moving the ball forward on science objectives and progress, because it allows for longer, more in-depth conversations. And finally, we should consider all lines of communication beyond just voice comms, including like the email and texting type capability. So with that, I think we're at the end of our time. Again, I said this in breakout number 2, but we really appreciate all of you guys who, brought your A game in the talks and the chat and chiming in verbally in the breakouts. The intent of this workshop really was genuinely to capture community input, and Jose and I and all of our awesome early career facilitators have a massive job ahead of us in trying to come up with these reports. But rest assured, you will have a lot more opportunity to engage on these topics moving forward via commenting on the reports, reports. Jose and I are thinking about ways that we could capture input beyond just comments on the reports. We heard from Jake and Sarah that we can expect more workshops on these kind of operationally based topics. And we just really want to make sure that we keep the lines of dialogue open to the entire community, because there's clearly some really wonderful ideas out there. So again, I want to thank the organizing committee, thank my co-chair, Jose, thank our early career facilitators, and maybe want to give an opportunity if any of our headquarters colleagues want to say anything. No pressure, but if you want to chime in, feel free.
Kelsey, I just wanted to say a quick thank you to you and Jose. And also to everybody who showed up and participated. Okay, thank you.
Yeah, agreed. Thank you, guys. Okay, Jose, I guess we're signing off.
Yeah, this was a lot of fun. So thank you, everybody, for your participation.
Thanks, everybody. Have a great day.
Bye.
Great team. Great team. Good job.
Thank you.
Thanks all. Thanks, Jim.
Well done.
Thank you.